Let's talk about research methods in IO psychology. You might have encountered research methods in other psychology classes, and maybe it wasn't your favorite topic in the world, but it's super important, especially if you're in the business of IO psychology. You want to know that if you're giving recommendations for how businesses, organizations, or office places should change the way they do things, you want to know that you are making those recommendations on the most solid grounds possible. So I want to clarify one thing from the grand world of research methods in this field, which is the differences between types of primary research methods. There are plenty of secondary research methods that use archival data or meta-analyses, other kinds of analyses that are really important, but primary research methods are the ones where you yourself are going out and collecting the data, or the researcher who wrote the paper you're reading went out and actually collected those data, him or herself. And there are a few ways that you can collect those data, and the way you choose to do that affects the conclusions you get to draw from the results. So to see the differences between three types of primary research methods, let's take an example research question. You might be interested in whether playing music in the workplace increases productivity. So you'd want to run a study, collect some data to ask the question, would people be more productive if there was music in the workplace, if they were listening to music while they were doing their work? And so let's look at some ways that you might attempt to answer this question using different research methods. The first approach would be a true experiment. The real hallmark of a true experiment is that it allows you to make causal conclusions. The point here is that you want to know, in this example, whether listening to music is the cause of increases of productivity. And the true experiment is the only way you can do that. Now, the key of a true experiment is randomization. Without this, the whole thing falls apart. And by randomization, what I mean is that each individual person in your study was randomly assigned to a particular condition. So randomization means each individual, totally at random every single time, it's being decided whether they experience one version of your experimental procedures or another one. And the trade-off here is control versus realism. True experiments are great. They are obviously the gold standard for a reason, because they give us lots of control over what's going on. But the problem is, the more control you have, the less realistic your experience might be. So if I want to control every possible other thing that could be going on in a situation, and I want to just look at that one variable that I think is causally responsible for my outcome, it means that the situations I'm going to have to put people in might be relatively less realistic than the kinds of situations I want to learn about. So let's take an example of how we could answer our research question using a true experiment. So again, our question is, does listening to music in the workplace increase productivity? And what we could do is create an experiment where people come into our laboratory or into a particular room, and we every single time randomly decide which version of the experiment they're going to experience. They could experience a task where they're not listening to music at all, and they're asked to do something productive. Or they could be in the experience where they're listening to music while they're asked to do something productive. Again, the important thing is here, every single person who walks into this room, it's a coin flip which version of the experience they're going to have. And so if at the end of the study, I look at all the people who had the version of the experiment without any music and the version with music, and I see this difference in productivity, well, then I get to conclude that there's a real difference there, right? If it's statistically significant, I can say that listening to music was associated with increases in productivity. Okay, but that might be outside of the resources someone has, or this might just seem too artificial, and a researcher might want to do something a little more realistic. So you could do a quasi experiment, which is going to look a lot like an experiment, as the name implies. But the difference is that you don't get to randomize the experience for every single person. You can't control for lots of outside factors. This is to say that at the end of the day, you're still going to be comparing a group of people who listened to music to a group of people who didn't, but that is sort of not as randomly assigned as a true experiment. But the benefit is that it's more generalizable, because I could do this in real offices and see what the differences are between those offices that play music and those that don't. So I got ahead of myself a little bit. The idea here that we could apply to our research question is that I could run a study where I go to different offices and I look for ones that are playing music, that have chosen to play music for their employees, and other offices that have chosen not to play music, right? So at the same time, I'm getting to compare a group of people who are working under conditions of music playing in the background to employees who are working under conditions of no music in the background. And here again, I might say that listening to music was associated with increases in productivity. The problem, though, is that I didn't randomly assign each individual to listen to music or not. And so now I have other explanations that could help drive this difference between groups. It could just be that the offices that decide to play music are different in lots of ways compared to offices that decide not to play music. It could also be that because I don't get to randomly assign individuals to their experiences, I'm stuck with having to say something about the culture of the whole office and not specifically productivity of each individual person per se. So we can contrast that with a final version of doing research, which is the non-experiment. The non-experiment is really the polar opposite of a true experiment, even if sometimes it looks like the same thing. The critical thing here is I'm not randomizing anything. I'm not comparing groups of people to one another based on groups I've made. Instead, I'm observing groups that already exist, right? I'm measuring a variable and I'm saying, is that variable related to the outcome that I'm interested in? So if I apply that to our example, I could just ask people, do you listen to music or not when you work? And I might find what looks like exactly the same result, which is that people who listen to music are more productive than people who don't. But of course, because I didn't randomly assign people to conditions, I'm left with lots of other explanations for why this difference occurs. And it would be wrong of me to use this as evidence to say, well, offices ought to make their employees listen to music, because we don't actually know if making employees listen to music is going to be effective. So let's compare these approaches, right? The graph might look exactly the same. That's kind of the point here, that I could take either of these three approaches and I could come up with a conclusion that kind of seems the same every time. But only one of these lets me draw a causal conclusion. That true experiment, that's the one that I get to say, listening to music makes people more productive. Because I have no other explanation for why those two bars are different except for the fact that I made at random some people listen to music and others not. So I can feel pretty sure that that in general is something I can bring to other offices and implement. The quasi-experiment and the non-experiment, I don't really get to draw that same conclusion, but nevertheless, I get to say that it applies in a more realistic situation, right? And so the balances between the costs and benefits of each of these are definitely worth considering. So again, to compare all these together in a way that helps you keep them straight, true experiments are true experiments because the researcher creates the groups. It was up to the researcher to randomly assign participants to the no music condition or the music condition. The quasi-experiment has groups that come pre-made, which is to say that there are some offices that have implemented this intervention and other offices that haven't. And so it feels a lot like an experiment because they were assigning their employees to listen to music or not, but still those groups were ready-made. The researcher wasn't able to do a true random assignment in that case. And then finally, the non-experiment is when people were naturally putting themselves into these groups, right? These groups already existed, and it was up to the individual to make the choice, him or herself, what they did, right? This wasn't about what they were made to do, either by a researcher or their office. It's just about looking at what are people naturally doing, and can we associate those natural variations with the kinds of outcomes that we care about. So the final thing I want to note is that non-experiments are really common because they're just way easier to implement in the world. And we can do them in realistic situations. I don't have to bring people into my controlled laboratory and randomly assign them to conditions. I can just go out into the world that's already happening around me and observe what's going on and just see if there are associations between the things that I'm observing. And I presented non-experiments like we were comparing two groups to one another, and you definitely can do that with these kinds of studies. But you're probably more familiar with the term correlational studies, which means that I'm observing two variables. I'm just measuring two variables as they naturally exist, and I'm looking at whether those variables are correlated. So this is why we can't make causal conclusions from these non-experiments, because as you've heard, I'm sure before, correlation does not necessarily imply causation. So in this case, I could ask a slightly more refined version of our research question, which is, does the more a person listen to music relate to their productivity week by week? So I could ask people in a survey, how often do you listen to music each week? And I could measure something about their productivity on a weekly basis. And I have all these data points from a handful of people in a survey, and I could draw a line of best fit through all of these points, and that's our correlation. Because that correlation slants upward, I can conclude that the more someone listens to music, the more productive they are. But again, still, here we don't get to say that listening to music is the cause of increases in productivity. It's possible that people who are already more productive are the ones who listen to music because it doesn't get in the way of their productivity because they're already so much more efficient. Or the same kind of person who listens to music just happens to be the same kind of person who's more productive. So, in summary, primary methods of research include true experiments, quasi-experiments, and non-experiments. They might look the same, but they allow for different conclusions. And why do we care? This might feel like a huge waste of time talking about research methods again, but it's almost most important in applied settings that IO psychologists find themselves in. You remember the scientist-practitioner model from last week, the idea being that you can enact real change, consequential change in an applied setting if you appropriately apply findings in the scientific literature. And if you don't understand how the science is done, you might make the wrong recommendations, which could end up costing an office a ton of money if, for example, you say you'd better apply this finding to your workplace if actually there's no good evidence that that's a good recommendation. All right, that does it for research methods. Again, there's a lot more to talk about, of course, with research methods, but because these three approaches to research can all feel the same, and it could be hard to distinguish them from each other, I wanted to go ahead and show you clearly what those differences are.